it's very clever. It says, please note while diabetes was suspected, it was ruled out based on the normal HbA1c level and therefore does not constitute the diagnosis. I mean, this is amazing. Like, okay, it did a little blip on the inference bit, but it didn't fall into my traps.
Because these models feel a bit more like they've also done it. Like they have learned, or during the training process, it was a bit more experimental in the sense that the model was able to try something, try again, try 10 times, and then learn from those mistakes and the correct ways to do something. So a bit more experimental versus theoretical.
When someone has bloody urine and has this characteristic kind of purplish purpuric rash, we're immediately thinking of rare diagnosis called vasculitis. And yeah, so in this case, ChatGPT 01 preview thought for 13 seconds. So once again, it's clearly thinking about these things, or at least recursively chain of thought prompting. And number one diagnosis, hinoxaline purpura. So it's a big step up from the previous models, you can see. Yeah, like all the suggestions are very good. Welcome back to Devanddoc. It is 10 p.m. on Saturday, 14th of September. Yeah, we weren't going to do a podcast episode, were we? But GPT 01 just came out, so here we are to share our thoughts.
Exactly. So I think we have to do something. I mean, everyone is already talking about that. What is interesting about this version, I think? We don't know much about it. At least for the previous ones, we knew at least a bit how they were trained, and we didn't know what data was used, but we knew the algorithms that were used or the way it was trained. Now we are much more in the dark, so a lot of the things, or everyone is currently trying to guess, what did they do to make it better?
Yeah, and there are some details, but yeah, obviously OpenAI now want to be the market leader, and they don't want to share their insights, so there are no longer transparent, reproducible papers published from the company.
I'll be honest, like on one side it makes sense. I get it why they are not doing it. I assume like they spent enormous efforts on this, and God knows how much money, and maybe don't want to be like, oh, here is everything we have learned, now you do it. So I get a bit why they're not sharing, but again, I would prefer that they share. I much more prefer the approach from Meta, where they just share everything and give you almost everything. They have released 3 models. It is nicknamed, now the new basically naming convention for them is O1, O1 Preview, and O1 Mini. O1 Mini is the smallest and the least smart of them all, but still being better than GPT-4o and basically everything else. The Preview is somewhere in between the like production ready O1 and the Mini. And of course the O1 is the best one, but that one was not released yet. So I think to the public we have only for now, at least the general public, we have only for now seen the O1 Mini and the O1 Preview, which is basically now accessible through the Chat GPT interface in OpenAI.
This is probably like their beta testing. It's probably like a chess game, like they're saying, oh yeah, it's preview, and then they'll use these outputs and how people interact with it to actually then release the actual real O1.
There is a couple of interesting things. So just to summarize basically the advances, or what do we get with this model? It is only a text-based model. So it's a pure large language model. We don't have vision, we don't have audio capabilities, we don't have anything, none of that. We are stuck with a pure text-based model. And basically the biggest feature they have added to this is what they are calling reasoning, or like more integrated chain of thought into the model itself. So now when you ask a question from the model, it has a thinking phase. So you ask it like, oh, what's the date today? And it says, I'm thinking for 7 seconds. And then it says, okay, it's Saturday. So those are, like, in short, what we have with these new models.
Yeah, and just quickly on that, we had, I mean, in a lot of our previous podcasts, even a year ago, plus we said reasoning is this capability that LLMs really lack and something they really need in order to be useful for healthcare and high-risk domains. And just very quickly, would you mind just maybe just summarizing for the listeners who aren't familiar, what do you mean by chain of thought?
So in the chain of thought, how we have done it before this model is basically you tell the model in your prompt, like you ask it a questions, and then you tell it things like think step by step, use the chain of thought reasoning. And that simply means when the model is responding, it is responding with basically a chain of thought. Like if you're asking it what is 7 times 7, it will say, first step, this is a mathematical query. Second step, okay, the first number is 7, the second number is 7, I should multiply them. Third step, 7 times 7 multiplied by 7 equals 49. So it's simply explaining all the reasoning steps it is taking instead of directly providing the answer. So you have two options, either 7 times 7 49 or 7 times 7 the whole reasoning process. How did it arrive to that answer? 7 times 7 is too simple, but imagine like you give it a much more complicated questions. Yeah, that requires like 5 steps. That's where we want to see how did it arrive at the answer and not just the answer.
Yeah, and we've all been there, when we're doing a maths class in high school, they ask us to show our workings. And sometimes as you're showing a working for a complicated algebraic question or calculus, as you show your working, you maybe then actually realize, oh crap, I actually can do this. And as you follow the steps, it actually becomes easier and easier.
Until now, we had to explicitly ask the model to do this. And in this new model, what is happening is that that's happening behind the scenes. And we don't even exactly see the reasoning steps of the model. So what happens with these models is you ask it a question. Like, for example, a patient arrived in the hospital, you have a big medical history, and you're asking, like, what's the diagnosis? And then the model will go through, it can be really hundreds of steps, going through the history, extracting the relevant diseases, understanding the risks, understanding interactions between medications, everything else like that can happen. And then basically providing you the answer plus a summary of the reasoning steps. So you don't see everything. You see a summary of the reasoning steps plus the answer. While the full-on process, how did it arrive at the answer, is for now hidden from us by basically OpenAI.
And that's interesting, right? Like, to me, I think they're trying to hide what they're doing in the background, but in their website, they try and justify this. They say, we're not showing the actual prompts because we want to know how users interact with the model, and we want to know when the model is lying. So it's just like a very strange reason they give to not actually show the users what's actually happening.
Yeah, I think that's standard. I mean, the obvious reason is if they show us everything, we will understand how it works and how it's trained and everything else. If they only show us pieces, then we cannot really go back to how this was done. There are a couple of theories that this is probably using like a Monte Carlo tree search, which simply means the model is exploring many different options. It's not just going one route, but maybe like, again, if it's a mathematical problem, maybe there are 10 ways to solve it. And then it is basically trying all the 10 ways like a tree. And then if it arrives at the correct solution, then it tells, okay, yeah, this is the best way to solve it. And this is the correct solution. And then it presents only that to the user. It doesn't tell you all the other things it has tried to get to the solution.
Yeah. And I read that paper as well. It's a bit like chain of thought, but with different. It's like a tree of chain of thought, and that was a paper, tree of thoughts.
Yes.
And I think that's what's happening here, because when you pose a question, I realize that the explanation it gives differs very highly depending on what type of question it is. So if it's a maths question, it will answer one way. And you can see on the internet, people are giving it like logic puzzles, and it will recognize, oh, this looks like a logic puzzle, therefore I'm going to follow this stream of thought, like this approach. So I think there is something, it recognizes what it is and then follows a specific chain of thought path, which they have kind of pre-taught the model, or either through reinforcement learning or whatever other way. So yeah, I think that is what's happening there.
And that's what you just mentioned is basically what everyone is considering as the secret sauce, which is basically more reinforcement learning. And there was a good quote by Andrej Karpathy, which was, I think, a year or maybe even more ago, where he was saying what the current models are missing is the way humans reason to solve a problem. Like when you are faced with a problem, you have many thoughts inside your head that are going into solving this problem, and not just writing out the steps to solve it, but also writing out all the other things that come to your mind to solve it. Like you don't want to just present the correct solution, but you basically want to present all the things you thought about while solving the problem, all the things that are implicit to you, all the things that are explicit, and then have all of that presented to the model so that it can learn from that, so that it basically learns the way to reason. It's not just, here is the correct solution, and then do that. And this is basically like coupled a bit with, again, the reinforcement learning from human feedback. We now don't know exactly how was the reinforcement learning done, but it is basically like a mix of model trying something, a human saying it's correct, or a human giving a piece of feedback and the model incorporating that. So it's more interactive than it was. Again, a lot of these are assumptions that people have. We are not 100%, but this currently seems like the most likely thing they've done.
Mm-hmm. Yeah, and using this approach, they have cracked a lot of the reasoning benchmarks. So they talk about MMLU and the big bench and different things like that. So they're all reasoning questions, and so far this has outperformed the existing models. And yeah, Jokos is showing us screenshots here.
Yeah.
And this maths competition, which is very hard, it's like a math Olympiad question bank, right? Which is astounding. You can see GPT-4o only had 13.4 accuracy, and then O1 had 83.3. Looks too good to be true.
No, I agree. I think like we only see these models shine over its complex reasoning. So if you're asking simpler questions or maybe more factual questions, these models will perform on a similar level as GPT-4o or any basically other of these large language models. But if you're asking something that requires quite a bit of reasoning, then they work much better. And there is one thing that is also important here. What we have got now is the difference between asking the model to think a bit more. So, yeah, they are showing that now it is important, or we can ask the model to think a bit more, and then it basically gets better. Like you can see these on the math benchmark. Yeah, so this is basically the place where they show on the math benchmark the difference between model thinking a bit or model thinking a lot. Because they have on the x-axis, they have the inference cost, and you can see that the more the model is thinking, there is, like, we can even have giant jumps in accuracy. Like for the O1 model, for the math benchmark, we go from basically around 60 to close to 80 just by asking the model to think a bit more.
But is that actually what's happening? Is it, when they say inference cost is higher to run the model, when they say think a bit more, they're running more iterations, more chain of thoughts, recursively?
Exactly, yeah. They are just enabling the model to run longer. So instead of limiting the model to whatever, let's say explorations of 5 paths in the tree, they just tell the model, okay, now you have 10 paths in the tree, or enable it to think longer and don't limit it to maybe, 10,000 tokens. They now allow it to think for 100,000 tokens. And we didn't really have these before. Like before, we didn't have the option that, oh, the model can just think a bit longer. You could, in a prompt, write, oh, think a bit more, but it was not really translated to performance directly. Yeah.
No, it's amazing. And it shows you that these scaling laws still apply. So so far everyone's talked about scaling laws for model training. So the more time you put into the training and the compute, the model seems to, and the more data you give, the model seems to still go up. And now you can see that even this applies even in the inference cost. So this is, I'd be very happy if I was NVIDIA right now. I think every single company is just going to be pouring resources into compute now. It's just going to be a war to get the most GPUs.
Most of the current models felt like they have never done anything. Like in a sense that this model has learned a lot just by reading everything ever, but it has never done a task. It has never done the task itself. Like very similar to like when you are watching a tutorial and you watch an hour-long tutorial and you're like, oh man, this is easy, like I get everything. And then you go and try to do it yourself and you're completely lost. You have no idea what you need to do. And by doing it, you learn 3 times more. Like just by the exercise of you trying now to, I don't know if it's a coding tutorial or something, just you now trying to implement something and do it, you learned 3 times more. And I feel like we are now going a bit into that area because these models feel a bit more like they've also done it. Like they have learned, or during the training process, it was a bit more experimental in the sense that the model was able to try something, try again, try 10 times, and then learn from those mistakes and the correct ways to do something. So a bit more experimental versus theoretical, maybe.
Yeah. No, I like that analogy.
Yeah. But we still have quite a few things that the models are not good at.
Yes.
So there is one very famous challenge. It is called the ARC challenge. And let me just show you how that looks. It is like, turns out for humans, it is fairly easy. I don't think it's as easy as they are saying. They're saying like 99% of people can solve this. I'm not too sure about that, but...
Oh, let's see.
So how it works is that you get a couple of examples. In fact, you get 4 examples of a task. Not 4 examples, 2 examples of a task. It is the input and the output. And what you need to do is figure out what transformation was applied to the input to get the output. And then do that in a test case.
So for our listeners, this is like a 7x7 grid, and then basically they're like Tetris blocks inside.
Yeah.
And I guess you're trying to see how you can move the 2 or 3 Tetris blocks to transpose and overlap on each other to make the final outputs.
It doesn't have to be just like transpose or move them, but it can also be add something to them.
Okay.
So
you can draw on the grid as well, basically, add blocks.
Exactly. So like in this example, we have like a couple of L-shaped or short L-shaped blocks, and basically the goal is just to add one missing dark blue
One missing block to make it a square. And the block needs to be a slightly different color.
Yeah, exactly. So like for me, like this is a very simple example. You have very complex examples of these, but for me looking at this, like it is obviously immediately clear what needs to be done. And
even this would be extra hard for an LLM. This would be extra hard for an LLM, right? Because it's image based.
Oh, it is. There is a very simple way to show these via matrices. And the models should be like extremely good at matrix stuff. So there is a very simple representation. Instead of showing a 7x7 grid, you basically do a 7x7 matrix. Each color is represented with a number 1 to 7 or 1 to 8, I forgot, or 9. And then that's basically it. So a blank is represented by a 0. And then you can easily represent this as a matrix and then ask the model, what do I need to do? What is the algorithm to basically solve this problem? There's a couple of more complications to this, but in essence, it is something like this. And this is a famous challenge because I don't think anyone was able to go above 50%.
But the humans are even humans are struggling.
No, humans are good here. So humans can get close to basically 100%.
Wait, what are those lines going above humans? Oh, okay, sorry. So this is a graph of different benchmarks.
Exactly, yeah.
So like, a lot of benchmarks have been cracked. So the ones that go above human performance. Wait, sorry, that's the score relative to human. Okay, so some AI models outperform humans. Like usually MCQ data sets like Squad 2.0. Okay, but for ARC, the AI has never come close to human performance.
Yes, for now I think we are around 50% below the human performance. And even the GPT O1 mini or O1 preview model is not coming even close, and we can in fact show the results. So this is basically the performance of all the different models. There are some models that are specifically made to solve this task, and like one of them is by Minds AI. I'll not go into the details of this model, but we can do that in another episode because I think it's a very interesting approach. But what's interesting to see here is that O1 preview and O1 mini are basically at around 21%, which is like in rank with the Claude Sonnet 3.5.
Sonnet's so good, man.
Yeah, so Sonnet is extremely good at this task. It could be also an advantage of Sonnet because it knows more about images and spatial reasoning, which these models don't have that. So I don't think it's a fair direct comparison. But it is showing that there is still a bit left to do, and maybe these models are not yet suitable for all kinds of tasks. It's not still a general model. I'm also sure this will improve a bit over the next couple of weeks, just because this was really the first test that was ever done, and maybe the authors didn't try too much to solve the problem or write nicer prompts or maybe do few-shot prompting or stuff like that. So I think there is some space for improvement that will happen over the next couple of weeks, but out of the box, we are still not there.
In this part, we're going to basically, we've fed GPT-01 different healthcare questions, which we know are pretty darn hard, and we know that other models have struggled with in the past, and we want to see how it fares. So the first one is my favorite acid test that I like to give large language models. And this is something that if you've been watching the podcast, you realize that it's a scenario that ChatGPT in the first year really struggled with, and actually a lot of models struggled with. It's a very simple question. It's saying a 35-year-old lady with abdominal distension, amenorrhea, so loss of period, and nausea. What is the diagnosis? And it's very, I mean, it's slightly tricky because you're tempted to go straight into the medical textbooks and reach a esoteric diagnosis. But the most common diagnosis, as you know, in a young lady with a big belly and stopping her period and nausea, morning sickness, the most common diagnosis is actually pregnancy. But initially, on Google or in the early iterations of ChatGPT, it would always go for the cancer option as the most likely diagnosis, so ovarian tumor. So yeah, let's see what ChatGPT 01 says. So immediately, most likely diagnosis is pregnancy, and the explanations. Oh my god, it even actually said nausea, morning sickness. Okay, so it's kind of cottoned on to our tricks. And yeah, it aced this question.
Yeah, I remember these questions from like the initial models that we were testing, and it was really like ChatGPT or GPT-4, and it was not that long ago where most models were failing on these, like basically springtime this year, most models or most commercial models were not able to solve this question.
Yeah,
Should we
and
go
then they all
to
had,
the...
yeah.
Go
No,
on.
I was going to say, and then they all had an update, and somehow now they're starting to answer it correctly. But yeah, don't know what happened in the background. But should we look at another question?
Yeah.
Okay, so this is one where I was trying to be a little bit tricky. So, as you know, in our clinical coding episode or medical billing, that if you're American, when patients come in, you need to essentially dissect what happened in that admission, and the hospital gets paid and remunerated depending on what gets coded. So there are reams of people hired by the National Health Service to sit there, go through these notes and pick out the key things that happened. And usually you map them to a classification code like ICD-10 or SNOMED. So I was very tricky here. I said, you've seen a 40-year-old lady in the neurology clinic, and I've said that they've come in with unilateral motor sensory loss in the right upper limb. And I've used tricky abbreviations as well. I said, so PMH, past medical history, HTN, CCF, AF, so heart failure, atrial fibrillation, hypertension. And I was extra sneaky here. I said, there's a family history of myocardial infarction. So the patient doesn't have it, it's the family history. And then I wanted to be even trickier. I said, her GP tested her HbA1c on suspicion of diabetes, but it was within normal limits. And then I also said, look, I would not write this in a real note, but I was being super tricky. And I said the GP also suspected radiculopathy, right, because of the limb motor sensory loss. However, there is a clear left hemispheric stroke on the infarct, which would explain her symptoms. Okay, so the model's thoughts for 13 seconds, which, okay, we're making it think. And looking at this, so based on the information provided, it's coded left hemispheric cerebral infarct causing right upper limb unilateral motor weakness, ICD-10 code I63.4, which is cerebral infarction due to embolism of cerebral arteries. So this is an interesting one because technically it's correct, like the patient has had a stroke, but at no point here did I actually infer what the stroke was due to. So the patient, for those of you who care, for those of you who are interested in neurology and strokes, strokes can be due to hypertension, quite commonly, but also from atrial fibrillation and irregular heartbeat. So here, the ICD-10 code, the stroke bit is correct, but it's actually inferred the etiology as atrial fibrillation or causing an embolic stroke. So it's kind of not fully, like, it's not right. And as a clinical coder, you shouldn't infer from the notes. So whilst this, I'll give it half a point, like the diagnosis is correct, but it's actually inferred a bit more. It's coded hypertension, heart failure, atrial fibrillation, and very clever here, it's coded for family history of ischemic heart disease. So not for the patient, but for the family. And lower down, it also, I think it mentions the diabetes bit, doesn't it? So yeah, it's very clever. It says, please note while diabetes was suspected, it was ruled out based on the normal HbA1c level and therefore does not constitute the diagnosis. I mean, this is amazing. Like, okay, it did a little blip on the inference bit, but it didn't fall into my traps.
Very nice. We also have one example that is from a paper we have published basically at the beginning of this year for a model called Foresight that can be used for like differential diagnosis, prediction of the future and all that. And at that time, we had a set of questions that we were basically asking like ChatGPT or GPT-4 or similar models. And in fact, all of them have failed on quite a few questions, and this here is one of them.
Yeah, so these are medical scenarios created by myself alongside 5 or 6 other doctors. And usually we have unanimous agreement as to what the diagnosis should be in the top 5 and what big diagnoses were missed. So ChatGPT, GPT-4 for this scenario, a 21-year-old presents to the clinic with hematuria and a purpuric rash. He was diagnosed with Crohn's disease when he was 19, and he suffered from bouts of bloody diarrhea at the age of 20. What's the differential here? And in the past, all the models would miss a vasculitis called henoxaline purpura. It's kind of rare, but it's also something that as medical students and as doctors we have in our heads. When someone has bloody urine and has this characteristic kind of purplish purpuric rash, we're immediately thinking of rare diagnosis called vasculitis. And yeah, so in this case, ChatGPT 01 preview thought for 13 seconds. So once again, it's clearly thinking about these things, or at least recursively chain of thought prompting. And number 1 diagnosis, henoxaline purpura. So it's a big step up from the previous models, you can see. Yeah, like all the suggestions are very good.
There is one other final question we can do just to test things out. And this one is in fact interesting because between 2 runs, basically prompting the model with the same question in just 2 different tabs, it gave 2 different answers.
Yeah, so this is, as doctors, we often have to convert opioid doses for patients of chronic pain, etc. So the scenario is as follows. A patient is on Oromorph, 10 milligrams twice a day, and a Butec patch, 5 micrograms per hour. I wish to convert her to just oral oxycodone. What is the equivalent dose? Even for doctors, this is a little bit tricky to actually convert these things, but and we know LLMs are not great at maths, so I thought this would be an interesting one to see how the model responds. It's thought for 10 seconds, and we can see here. So I've actually I double-checked this with a palliative care consultant because I know these conversions can be tricky. So the answer to this question is basically for Oromorph, oral morphine, 10 milligrams twice a day, that's equivalent to 20 milligrams of morphine a day. And then the Butec patch, which contains buprenorphine, which is a transdermal opioid that's more potent. So it's well-known knowledge that one of these 5 microgram per hour patches is equivalent to a 12 milligram Oromorph conversion. And this is what the palliative care consultants do. This is what's said on the British National Formulary. So the interesting here is that somewhere in its database and knowledge, GPT-01 has gathered that 1 milligram of transdermal buprenorphine is 75 times stronger than oral morphine. But actually the literature fluctuates a bit on this. It's not clear if it's definitely 75 or it's between 50 to 100. So if you follow its chain of working, it's correct, but it's pulled this 75 out of like dubious data, whereas the convention and the formulary guidance for prescribing would be 12 milligrams. It's actually slightly calculated this wrong and slightly underdosed the patient, which is okay. Better to underdose than to overdose. The interesting thing is, like Jaco said, we have done this on multiple runs, and on the first run, it didn't do this little calculation bit. It did say one of these patches is equal to 12 milligrams of morphine, and then it did it right that time.
Do you want to go through the rest?
So, after that, it follows the working and it does a conversion. Typically, you divide by 1.5. I think that's correct. So in the literature, you divide by 1.5 to 2, depending on how safe you want to be, because there's this kind of cross-reactivity. So sometimes you go on the more safe side and give a bit less. But nonetheless, it's calculated around 19 milligrams of oxycodone per day. And therefore, we'd recommend the nearest practical dose, which is very nice of it to suggest, is 10 milligrams BD. So I think overall that's pretty darn good. I would say in general, because maybe I'm just cautious as a clinician, I wouldn't round up, I'd always round down. So here it says, 90 milligrams per day, let's go up to 20. I'd probably actually start on 7.5 milligrams BD and then go up from there. But either way, I think I'm impressed, but there was a small error there, which would slightly concern me. Like I wouldn't let it run wild yet still, despite all this apparent improvement in reasoning.
Yeah, I think what was just interesting is that between different runs, you get different answers, which was maybe a bit more pronounced in the older models, but now it is happening a bit less, but it still happens. Again, I think this is mostly fixable, and this can be done with having a database of documents where you can do retrieval augmented generation, or where you can pull the facts from, so that it's not pulling this knowledge basically out of a database that might be imperfect. Like, these conversion rates should really be pulled from a proper maintained medical knowledge base and not from the internet, in other words.
I think overall it's impressive, and actually we tested a lot more diagnosis scenarios, and it was very hard to crack it, actually. Like, it almost, we say you should never use it for diagnosis. LLMs are untrustworthy, overconfident, but bloody hell, like, it's getting the correct diagnoses very, very frequently, like scarily so, actually.
Yeah, it was hard to find something it's completely wrong. Like, it made a giant mistake that you should never do. It's usually there is a bit of something wrong, or a small piece missing, but not completely. Like we have seen in the clinical coding example. Like, it's a bit wrong, but it's still correct, in fact.
Yeah. But, so I guess the important nuances here are that it's actually picked a code that isn't billable. I mean, you can definitely improve on this, but this is what hospitals care about, right? Like, if you want to build a business case, like, you can't have an LLM coding things that aren't billable. Like, you can't use the wrong code, because that means the hospital will miss out on potentially millions of pounds per year, right? Just because of that slight difference, but it's important.
No, I agree. But again, we are working on models that are not fine-tuned for this at all. And I think with a bit of guidance or a bit of fine-tuning for these use cases, and even like in context prompting or few shot prompting or something like that, it would get much better.
Yeah, I mean, to be continued, right? There's many startups trying to build on this, and we'll see who's first to the game and who actually does it well.
Okay, awesome. I think we have covered quite a bit today. We'll do more tests on these models as time goes, do a bit more extensive and proper tests, and we'll see where we end up. Thank you very much for listening, and we'll see you next time.
Yeah, like and subscribe, and see you soon.
Bye-bye.
Bye.